All right. What'd you guys put for the first one? Which one's linear? It is not the first one. The second one is linear. Second one is linear. And if you can plot some specific points, you should do that. So like, what's a point you could put on that? Zero, the origin, most of them start at the origin, the parent functions, they haven't been moved around. So 0, 0, 1, 1, 2, 2, 3, 3, you know, so on and so forth. The first one gets people. All right, so first one is constant. Now, I made it 2 because I had to pick a number, but it could be f of x equals 1, f of x equals -3, like anything that's just a number. Constant means lack of a variable. There is not a variable in there. So it's going to be a horizontal line, in this case at 2, but it could be, like I just said, any other number, as long as it's just a value, not a variable. It's lack of a variable. All right, how about 3? Yep, absolute value. That one usually goes okay. And what's that shape? A V, centered at the origin. And so you get 1, 1, 2, 2, 3, 3. It's linear, except the negative part has been reflected up here. It is linear. It's just that like this negative part is reflected up there because an absolute value turns everything positive. It means a distance from 0. That's why it's all positive, because you can't have a negative distance. But it is linear, just with the negative part positive. All right, this next one. All right, so this one is called greatest integer. Did you see that in Algebra 2 at all? I usually get some yeses and some nos on that one. Your teacher might have shown it to you. You don't do a whole lot with it. It's the staircase one that's nicknamed as the step function. Let me draw it and then I'll explain to you like why it is, because usually people are like, I hate this one, but it's actually very applicable. You start at the origin like always. So like put a point there. And here's what happens. You stay on that step until you get to 1, where there's an open circle, looks like a little barbell, and you just jump up to the next step. And then it's like this infinite, function, yeah. Yes, well, its official name is greatest integer. So here's how that's applicable, because I think that it actually is kind of cool. So like, say you were going to rent a vehicle from Home Depot. Like, you know how you can rent trucks from them to like move stuff, or say you're gonna rent a U-Haul. I don't know, say you're gonna rent a vehicle. You know how they charge you by the hour? So like there would be a price for the first hour or whatever. But if you have it for an hour and a half, what are they going to charge you for? So like, you know how it jumps up to the next step? So if you have it for an hour and 5 minutes, or an hour and 15 minutes, or an hour and a half, or an hour and 59 minutes, they're going to charge you for that 2 hours. And then when you get above 2, you're going to jump up to the next step. Do you see what I'm saying? That is what a step function, the greatest integer function. All right, how about 5? Quadratic. That name is weird for that, because quad means 4. I mean, like, I get it, but it's weird because it's squared. So like, oh, it's weird. What is the shape for that one? A U. And do you know what its officially, like, its official name is? It does start with a P. Paralysis. It does sort of sound like a disease. Parabola. I thought I heard somebody back there say it. Okay, so your points, you're gonna have 0, 0, 1, 1, and then where's the next point? Because it's not 2, 2. It's not 2, 3. 2. Why is it 2, 4? Yeah, because 2 squared is 4. Where would the next one be? It would be 3. Hey guys. 9. 3, 9. That's gonna go off the grid though. Are you guys okay over there? You know this is being recorded. Yeah, okay. All right, how about this one? Yeah, don't overthink it, guys. Square root. So the quadratic and the square root are inverses of each other. You're just going to take the parabola and turn it on its side. The only thing is you only get the top half of it. So these are your points, 0, 0, 1, 1, and then instead of 2, 4, it's 4, 2. We're going to get to the unit where we do inverses. You just, switch everything. The output and the input get reversed. You don't get the negative part. You can't square root a number and get a negative result. You know what I'm saying? Like, You can't square root something and get a negative output. Yes, sir. Oh, next one. Oh, you're ahead of me. Okay, hold on. Okay. Does anyone know the name? Cubic? And what is it shaped like? Like a snake? I usually just get people that do this. They're like, oh, it looks like people just want to act it out. Now let's get the actual points on it. So 0, 0, 1, 1. Now what is, I was holding my breath on this one, see like how things go. 2 cubed. Good, it's 2 times 2 times 2, which is 8. So you get 2, 8, which I believe is right on the edge of the grid. And then for the odd powers, you can get the negative. Like when you square something or any even power, it's going to always be positive, but the odd ones, you can get the negatives. So your reflected points are going to be down here and it looks like a snake. Or I call it a wiggle, whatever you want to call it. Yeah, well, whatever makes you remember it, like you do you. All right, and then what is this one called? Cube root, good, thank you back there. And it is the inverse of cubic. So you're going to take all these points and reverse them, which 0, 0, and 1, 1 are going to be the same. But then instead of 2, 8, you're going to have 8, 2. Now, I get a lot, people are like, I can't remember which one is right side up and which one is sideways. So if this helps you, the sideways one is like roots of a tree grow out sideways. So the one with the root in it is the sideways one. I don't know if that helps or not, but for what it's worth, the root one is the sideways one. I made 9 and 10 the same. I just did 2 examples of it because sometimes like when I do the first one, everyone's like, oh, I sort of remember that, but like we need one more to help it sink in. Does anyone remember what these are called? It does begin with a P. Good, polynomial. And again, usually when I do the first one, everyone's like, I'm not sure. But when I do the second one, it's like, okay, yeah, I remember that. Because it's very much about like pattern finding. So you plot the zeros. So boys and girls, what makes this factor 0? 3, right? Because 3 minus 3 is 0. So we're going to plot 3, 0. And then what makes this factor 0? Yep, -4. So 1, 2, 3, 4. Now, those are the only points that you get to plot specifically. The rest of it is going to be like, good enough, right? This is like doodling in math class, okay? I like this unit. A lot of people end up liking it too because it's just about a pattern. Now, do you see a negative out front? No, that means the right side goes up. If there was a negative there, the right side would go down. Positive up, negative down, okay? And then do you remember the pattern for the exponents? If there's an exponent of 1, which means there's nothing written there, what do? Go straight through. 1 means linear. If it's a 2, bounces because 2 means quadratic. And if it's a 3, it wiggles or does the snake, whatever, because 3 means cubic, okay? So we're going to connect to the dots and just do those. Now for the 3, I don't see a power there, so it's a 1. We're going to just go straight through. And for the -4, it's squared, so we're going to do like a parabola and bounce off of it. And again, usually everyone's like, oh, I sort of remember that. And then we just do one more to like make it sink in. What are the 2 points that we could actually plot on this one? Yeah, which would be -4, good, and 5. Do you remember this sort of from last year? No? I'm trying to think where that would fall in. I haven't taught algebra 2 in several years now. Somewhere in like the 3rd quarter, I think, is where you hit that. You guys at least got all of algebra 2. Like my pre-calc classes last year, they had the year where it was like they either had it first semester or second semester, and so for some of them they hadn't had math for like almost a year. Do you know what I'm talking about? Like chaos. Anyway, you guys at least had a sort of normal algebra 2 last year. All right, do you guys see a negative out front? Yes, that means the right side goes down, positive up, negative down. When you connect to the 5, the x minus 5 has a cubed, so we are going to wiggle. I always get people that are like, I can't draw that. That's fine, just write the word wiggle next to it. It's good enough. But it just looks like a cubic function. And then what are we going to do with the -4? Bounce, because it's squared, so it'll be like a parabola. So those are like little doodles. Those are cool, I like them. I made 11 and 12 the same parent function as well. I just threw a squared into the second one. Does anyone remember what this is called? Oh, good. What is the root word of rational? Ratio. Ratio means fraction. Fractions scare people. I'm really not sure why, but I'm going to, again, do a lot of pep talking and hand holding to get you through that. A fraction is just one number divided by another number. That's all it is, right? I just don't like them. Now, I actually kind of like graphing these because you don't have to be so specific. Like up here, we were plotting all these specific points. These ones are like, good enough. We're going to put in our little invisible fences here. They're going to go on the axes. I know it's kind of hard to see because they're on the axes. Does anyone remember what those are called? Asymptotes. Whoever came up with that name, I need to like have a conversation with them. And then it looks kind of like, I say it looks like an hourglass. It's just going to sort of coast along. I'm not plotting any specific points. Just don't run into those invisible fences and you're good. And then this one's going to be like almost the same. You're going to have those dotted lines on the axes for the asymptotes. It's just since it's squared, both arms of the graph are positive, so they're going to be above sea level. I call this above sea level and below sea level. I just call it above sea level and below sea level. Although I say that so much and it becomes so important in AP Calc that someone actually wrote, like, you have to do justifications, and the reason why would be like because the graph is positive, and someone wrote on their test because the graph is above sea level. I gave credit. I was like, don't do that on the AP exam though, okay? Right. Like, yeah, they're gonna be like, no credit. Because they're evil. All right, what is this one called? Exponential. X is the exponent. And then this one is logarithmic. Yeah, because it says log in it, right? Now, those are also inverses of each other. So when we graph this one, we just flip all the points to get this one. They each only have one asymptote. Exponential is the horizontal one. Logarithmic is the vertical one. Again, they're inverses of each other, so I'm kind of doing them together. Because once we do this one, we're just going to flip all the points to get the other one. So let's just try plugging in some numbers. Always nervous about this question too. Let's say we plug in 0. What is 2, or any number really, to the 0th power? Think before you answer. It is 1. Anything to the 0 power is 1. So we get 0, 1. A billion to the 0th power is 1. All right, now let's plug in 1. 2 to the 1, like 2 to the first. That's 2, so we get 1, 2. And then if you plug in 2, 2 squared is 4. So it looks something like this. And I always just go like this while I'm talking about it. It's smooth. That's what I call that one. Smooth. Did you ever hear or read this somewhere? Such and such grows exponentially. What they mean is grows really, really fast because it's like, now you're going to reverse all those points over here. So instead of 0, 1, you've got 1, 0. Instead of 1, 2, you've got 2, 1, so on and so forth. And it's going to be the exact same thing except sideways. You have not seen the sine and cosine graphs. This is the one thing that's going to be brand new to you. But we are going to write them and say them correctly. Sine is S-I-N-E. That's how you spell it. Sine, and this is cosine. They are waves. I always go like this while I'm talking about it. Like, has anyone taken physics? Do you do sound waves? Or, oh, you have it like, oh, it's good if you take them like this class and physics together, but it's going to be like those sound waves. Here's how I remember them. Sine starts at the origin and then waves. So if you start at the origin, it's going to go up and then back to the origin and then down. That's going to be like your wave. Now, I'm not grading your art skills, but make an attempt to get it to be a nice smooth curve. Like it shouldn't be a jack-o'-lantern mouth. Like it shouldn't be sharp edges. Like make an attempt. So sine, that looks lovely. So sine starts at the origin, cosine starts at 0, 1, and then waves. So if you just remember where that starting point is, then you're good. All right, this last page is everything a review of linear equations. So just lines. This is basically algebra 1 review. All right, so slope. Slope is m. Does that make sense? Do you remember how to find a slope? If you have 2 points, like the formula? It actually doesn't matter if you do y1 minus y2 or y2 minus y1. It won't. So you're both right. I usually write the 2 minus the 1. It doesn't make a difference. And as long as you do the x's the same way. So it's rise over run. The y's, you subtract them, over the x's, you subtract them. So if you can subtract, you're going to be just fine. All right, point slope form. It is y minus whatever your y number is. So y1 or y2, it doesn't matter which point you use, equals your slope, and then x minus your x number. And then slope intercept is the one everybody always can shout out. Y equals mx plus b. All right, so here are our 2 points. We're going to find the slope. Subtract the y values. So it'll be 7 minus -2. So I'm subtracting the y values, and then subtract the x's. -1 minus 2. That is an awful lot of negatives, and you don't get a calculator in here, so be careful. Our numerator is going to be what? 9 over -3, which would just reduce to -3. So we already know the line should be going down, like it should be decreasing, negative slope. Point slope, it does not matter which point you use. I always use the first one for no other reason than it's the first one. You have to pick one and go with it, all right? It's going to be y minus the y part of the point. So that would be y minus -2. Are you following me there? That would be y plus 2. Y minus -2. So y plus 2 equals slope, which we just found, -3. And then in parentheses, x minus the x part of your point, which is 2. Hey, Ms. Cole, what if I use the other point? That's fine. It doesn't matter. You can use either one. Now, if you get asked to put it in slope-intercept form, the y equals mx plus b, there are only 2 steps. You're going to distribute whatever the slope is, and then add or subtract over whatever number is next to the y, okay? So we're going to distribute the -3. That will give us -3x plus 6 and then subtract over the 2, you'll have y equals -3x, what is that, plus 4. So that one turned out kind of nice, but sometimes you end up with fractions. You don't get a calculator, and so it's a bummer. Now, there's like a million different ways you could go about graphing this. I would say just plot these 2 points and connect them, right? Like you could actually do the graph before you even do the rest of the work. Or you can use this, like you can start by going up 4 and then use your slope of -3, go down 3 over 1, and then just keep doing that. Making our Algebra 1 teacher proud. How long ago was Algebra 1? See, I like to review this because Algebra 1 was a long time ago for you guys, right? Like, but yeah. So it's been a minute. Yeah, isn't point slope form great? You just write it and that's the answer. That's it. You just write it and walk away. It's fantastic. All right, let's try another one. Slope. You're going to subtract the y's, so 2 minus 1, and then subtract the x's. So it'll be 2 minus -2, which will be plus 2. So that will be, what, 1/4? So that's positive. I know that this line should be increasing. It should be going up 1 over 4. So point slope. I always use the first point for no other reason than it's the first point. Again, it doesn't matter, okay? It'll be y minus what? 1, good, the y part of your point, equals your slope, 1/4, parentheses, x minus the x part of your point, which is -2. So it'll be +2. And that's the answer. That's it. You get to just do that and walk away. Now, if you want to change it to y equals mx plus b, that's going to be annoying because there's a fraction, but we can do it. Okay, there's two steps. You're going to distribute the 1/4 and then add over the 1. So this will be y minus 1 equals. Now, if we distribute that, that'll be 1/4 x plus 1/4 times 2 will be 2/4. 2/4. What does that reduce to? 2/4 is a half. A fourth times 2 would be 2/4, which reduces to a half. Then you're going to add over the 1. So it'll be y equals 1/4 x plus, now it's 1 1/2. I don't want 1.5. What would that be as a fraction? 3/2. Good. You don't want to use that to graph because you'd have to put a point at 1 1/2. Okay, what I would do is just plot these 2 points and connect them in this case. Just plot these and connect them. -2, 1, and 2, 2. And you can see that the slope is a fourth. And if you want to continue that, then you can. It's up 1/4. Oops, did I go 4, 2, 2, 3, oh, one more. To be real honest, the Algebra 1 stuff is what gets people a lot in this class because it's just been so long since you've covered it. Oh, yes, sir, good. Yeah. It's fine.
Like, if you just like swap those points, then you'd be able to find the slope that would be able to connect them.
Yeah, and I have one here that we're going to figure out from the graph. Like you can look at the graph and figure it out almost backwards. Yeah, absolutely. Yeah, you can do the problem here. Do you want to do that? Let's do that. If you plot these points, 7, 0, and then -1, 3, you can just like count how many boxes down and over it is. Like that's another option that's perfectly valid for how you can do the problem. So what's this slope going to be? It's going to be negative. What do we go? Down 3 and then over 8. I believed you. I just wanted to check that I pointed in the right spot. So yeah, you can do that as well. Just plot them and connect them. And then just count the little boxes to get your slope. All right, so point slope form, it would be y minus what? 0, which is fantastic. Y minus 0 equals -3/8. That's your slope, parentheses. Wonderful. I know some of you are zoning out because it's been a long block. This is recorded, and if you zone out, you can watch it again. Isn't that great? Now, if you want to change it to y equals mx plus b, the awesome thing is that you've got 0 there, so you don't really have to worry about that. It'll just be y equals, and you have to distribute that -3/8. I know some of you are already getting nervous about that, but it's going to be totally okay. It'll be -3/8 x. Now, when you multiply negatives, what's going to happen there? Yep, it'll be positive, and all you have to do, kiddos, 3 times 7, 21, and it'll still be 8. No, that is yay. Every time you get a correct answer, it's like a celebration. So same thing for this one, except I just went ahead and gave you the line so you don't have to graph it. Slope, we went, what, up 2 and over 5, 2/5. Y-intercept, -3. It's technically 0, -3, like if you're being super official, which we should be because it's an advanced class. So, and then slope intercept form, it'll be y equals 2/5 x minus 3. You just take the slope and the y-intercept and throw them into the equation. These last two, as a heads up, these are the horizontal and vertical lines. They throw people because I know one is one way and one is the other way, and everyone's always like, oh, wait, which one's which? Did your teacher give you the acronym HOI-VUX? Did you use that? Okay, so let's go over that real quick. Horizontal lines have a 0 slope. They are y equals. Vertical lines have an undefined slope. They are x equals. If that doesn't help you, forget it. If it does help you, great. It's not like you have to use that. It's just, it's not a word. It's just like a way to help you remember. All right, so when you plot these, 5, -3, and then -6, -3, and connect them, what kind of a line do you get? Horizontal, good, like the horizon. So what's the slope for a horizontal line? 0? Yeah, horizontal is 0, and it's going to be y equals not 0. In this case, it'll be -3. It's wherever the line is. Oh, constant. Do you remember the constant one on the front page? Just like that. Well, no, never going to be 0. It's always whatever number you happen to be at. So here, let me show you. So this one, like if you do 4, 1, and 4, 9, you know what, that's going to go off the grid. But anyway, 4, 1, and 4, 9, if you connect them, what kind of a line did you get? Vertical. So your slope is undefined. That would give you a 0 denominator. You're not allowed to divide by 0. Talk about that really fast. I know you're like, we're sick of listening to you, but just really quick. If I asked you guys to divide yourself into 7 groups, great, you're already in 7 groups. You can divide by 7. If I said divide yourself into 2 groups, you could divide in half, right? If I said divide yourself into 1 group, that's all of us together, yay. But if I said divide yourself into 0 groups, but you still exist. You know what I mean? So you can't divide into 0 groups because even if you left, you still exist. So it's not like a possible thing to divide. Anyway, this would be x equals what? 4. Sorry, my brain went silly for a second. X equals 4 for that.